Hello, so today we're going to talk about bias theorem. So when we're talking about bias theorem, we have three important terms to discuss: independent events, dependent events, and conditional probability. Right? So let's start off with the first one, which is independent events. Now, what are independent events? Just like the name suggests, let's try to draw out a definition, just according to the name. And then we'll move on to an example to make it much easier to understand. So the word independent itself suggests that it should be an event which is whose occurrence is not supposed to be dependent on any other kind of event, right? So, and that's exactly what the definition is. Independent events are events whose occurrence is not dependent on any other events. So let's try to draw an example. So while tossing two coins, for example, you have coin A and you have coin B here. This is A and this is B, right? So the probability of getting a head or tail for coin B, which you will be tossing in your second attempt, is not dependent on the outcome of whatever you get, either a head or a tail, after tossing the first coin, in this case, A. So A has its individual probability, which is 1/2, because there's, a head and a tail. So you'll either get a head or tail, but whatever the result, it doesn't matter what it is. In B, you will have a probability of 1/2 again for whatever the outcome is. So the event of, like tossing coin B, the second coin, the occurrence of getting a head or a tail, or whatever the outcome is clearly doesn't have anything to do with the outcome of A. So that's what independent events look like, right? And there's another thing that you need to remember, that for independent events A and B, the probability of getting A and B, this sign here, the intersection sign, just suggests that you have there is this occurrence of both A and B. So the probability of both events A and B occurring can be found by multiplying the probability of the event A occurring into the probability of the event B occurring. Okay, so that is what we know about independent events. And now let's move on to dependent events. So we will be covering the second point that we talked about, that we'll be discussing now. What are dependent events? Let's say you have a bag with, marbles on them, and you have both red and black marbles. Okay, so let's say you have like 4 red marbles and you have 3 black marbles. Okay, so the first event, event A, is that you need to take out 1 red marble. Okay, and event B is take out 1 black marble. But the catch here is that after taking out that one red marble, you do not, after you've taken this out and it's not here anymore. Oops. After you've taken out that red marble, you do not replace it back into the container before you've performed event B, like taking out a black marble. So without replacement, if you're doing it, the probability of both event A and B occurring, they are dependent on each other. Now, how does that work? Let's draw out a tree for that. So in your tree, the first event is either red or black, right? So in this case, we said the event A is getting a red marble initially, so we will try to expand this. So you either get a red or black in your second attempt. So we are talking about getting a red and then getting a black. So this is our path, right? So if you see that initially, when I want to pick my first marble from when I'm going to take my first marble from the box, how many marbles do we have in total? 1, 2, 3, 4, 5, 6, 7, right? So its denominator is 7, and how many red marbles do we have? 4. So it's 4 over 7. The probability is 4 over 7 of getting a red marble in the first attempt. And then when I'm not putting that marble back, right? When I'm not putting that marble back in the container, the total number of marbles get reduced by 1, right? So do you see how the probability of my second event is going to be affected, since the total number of marbles is no longer 7, rather it's 6 now. So the probability of getting a black marble is 3 over 6. But if I replaced it, if I replace it back into the container, then it will be different. It will be 3 over 7, right? So that's what we're talking about here. So the probability of getting both event A and event B done is 4 over 7 into 3 over 6. So that's like 2 over 7, right? Now, that's what dependent events are. Let me quickly write down a few things about dependent events. So dependent events are events that events whose occurrence is dependent on other events. Okay, and also probability of A intersection B is equals to probability of A into probability of So this is where the concept of conditional probability comes. All right, so we will try to understand what conditional probability is. All right, so in case of conditional probability, you'll see that I have written down how it is read: probability of A given B. So the given part, given literally means something has occurred already, an event which has already taken place. That's what given means. So the given part is always written as a second letter right after the line that you can see here, which is dividing A and B. And also that is equals to the probability of A intersection B, and the given part again, which is probability of B, is written as a denominator. Again, you'll see probability of B given A. You see how the letter comes as a second letter, the given one? So the probability of the event that has occurred already or is stated as given is written as a denominator. Now that's how you remember how to write the notations. Other than that, like the intersection is same for both, right? So that's what conditional probability is written. That's how it is written down in the form of notation, and that's how I remember it. So let's say I tell you that find the probability of getting like I'm trying to relate it to the previous problem that we were doing with the marbles and everything, right? So if I tell you find the probability of taking out a black marble as in the second attempt, given that a red marble has been taken out in the first attempt. All right. So in that case, I would be writing it like this. Given red, if I'm not wrong. Yeah. So probability of red, intersection black. Okay. So what is the probability of getting? What is the probability of getting a red marble? The probability of getting a red marble is, there are a total of 7 marbles, right? So probability of getting a red marble is 3/7. Oops, no, it's 4/7 because there are 4 red marbles. So 4 divided by 7. And what's the probability of getting a red and a black? It was 2/7. So 2/7. So I forgot to write here a probability of black. So what's the probability of getting a black marble? Just a black marble? It is 3/7. So let's solve this and see what we get. Uncertainties. Which is 3/14. This was the probability of, given that a red marble has already been taken in the first attempt, and you are to find the probability of getting a black marble in the second attempt, right? So let's see how we derive the Bayes theorem from the concept of conditional probability, right? So like you saw that probability of A and B is equals to, now probability of A intersection B is the same as probability of B intersection A. I mean, they mean the same thing, right? So both are exactly the same. So we can actually form two different equations from here, one for this and one for this. So, we can write probability of A intersection B is equals to probability of B intersection of A is equals to. These two basically, they mean the same, exactly the same. We can say that it's probability of B into probability of given B, A occurs. So we can write this is equivalent to this, right? So we can write P of B to A given B is equal to probability of A into probability of B given A. Now, if I subject this, right? If I subject this, I can just write probability of A given B is equivalent to probability of A multiplied to probability of B given A divided by probability of B. Now, this is what bias theorem looks like. And these have specific names. These are just the terms used in bias theorem. This is called the posterior probability. Posterior probability. This is called the marginal probability. And this is called the likelihood, and this is called the prior probability. Prior. And what? If you want a clear image of the whole thing, I'll just erase these so that you can have a clear image of the entire thing. Let me just write it down here. So bias theorem A given B is equals to that's it. So I will be talking about naive bias in the next video.